Alrighty. Buckle up, everybody. This is going to be a long one, probably. There's going to be a lot of problems. Now, of course, this isn't a required video, but, this is going to be the classwork for all of these rational functions. I'll tell you this. You do all of these, like if you do all of them, you're probably going to make 100 on the test. Yeah? Probably going to make 100 on the test because this is a lot. Okay? Now, remember, I don't expect you to do all of these problems in class. I don't expect you to do these for homework, blah, blah, blah. These are just extra practice problems, and some of these are really here to challenge you and push you to think. I will say, if you were to start relying on this video key too much, you're going to miss out on your own learning, okay? Use it for cases where you really get stuck, but don't just hit a roadblock and sit there for 5 minutes and then give up, okay? You got to learn some perseverance. You got to learn how to deal with a problem for an extended amount of time, okay? So maybe you're looking at it, maybe you spend 10 minutes on it and you throw your hands in the air, you say, I can't do this. No, some of these you might have to stare at for 25, 30 minutes, maybe an hour. Don't rely on this video key to get through all of them, okay? You won't learn that way. Trust me, you won't. You might see how I set it up. You might start to understand kind of the basic premise. But when it comes test time, when it comes to time to actually apply math to a real-world setting, you're not going to have it. It's just the honest truth. You're not going to have that skill, okay? I just want to say that. Now, of course, you can come here for help. That is the point of this video. If you are truly stuck, that is why I'm doing this. I'm just saying don't use it as a crutch, okay? Okay, let's get started. So I've tiered this into 4 levels of problems, okay? We're going to start at level 1. These are the easier tier problems. Now, before I start this, I just want to say there's a few things you want to write down for these types of problems. As a reminder, sorry, I'm yawning. Video ruined. Got to restart. Just kidding. I yawn a lot. Have you guys noticed that? I don't know. I feel like I have a condition. I feel like I just terminally yawn. I don't know if there's a thing for that. I don't know. It's not because I'm always tired. I just do it. Anyway, okay, shut up, Mr. Spade. Get to the video. So remember that there's going to be work problems, and there's going to be sort of, what did we call them? Uniform motion problems. If you watch that 9.3 lesson video, right? So depending on the context of the problem, you're going to use something particular for that kind of problem. But when you're talking about rates, which all of these are talking about rates, here's a few things to keep in mind. And so maybe I'll write this up here. Speed is distance over time. Now, as long as you know this, you can do these problems, okay? As long as you understand this, you can get this. So that's how speed is. If you solve this equation for time, then time is distance divided by speed, right? If you think if you multiply time to the other side and divide speed to the other side, time equals distance over speed. We're going to use this one a lot, okay? Because a lot of the times they give you like a set amount of time that has occurred, and so you add 2 or more sets or intervals of time together, and that equals your total time, okay? And of course, the last one would be that distance is speed times time. I'm out of space. Let's just drag it over here. Distance is speed multiplied with time. Okay? So if you're adding distances and you know speed and time, you can do this. Okay. Recommendation. When you read these word problems, write down what you know. Okay? Just write down what you know. And maybe if you don't know something, give it a letter, give it a name, call it something. Okay? Let's start with number 1 here. Alyssa hiked up a mountain at a pace of 2 miles per hour and hiked back down the same path at 3 miles per hour. If the total travel time, excluding rest stops, was 10 hours, how many total miles did she hike on the mountain? Now notice, the question is how many miles, okay? So our goal is to find distance. Yeah, keep that in your head. Always underline what the question is asking so you know where you're going, okay? I want to find distance. Let's see what I know. I know her speed up the mountain, right? So I'll say that her speed up is 2 miles an hour. And I know that her speed down is 3 miles. Okay. I also know that the total time was 10 hours. Okay. So if you think total time, well, total time can be found if you say time going up the mountain added with the time going down, that equals your total time. Right? I mean, that makes sense, right? Of course, we are excluding rest stops because who on this earth is going to hike for 10 hours straight without taking a breath, right? So we got time up, we got time down, equaling total time. That's our variable we're looking for. We have an equation for time. It's distance over speed. So it's the distance going up over the speed going up. Now, hold up. Do I know the distance? Do I know how far she went up? No, I don't. So let's call that something, maybe D. D equals distance. Well, going up and down the mountain is just one way. So let's call that distance one way. Okay? Because it's the path up the mountain and it's the path down the mountain. So your time going up is distance, D, divided by the speed going up, which is 2. Add it with the time going down. Well, that's the same distance, D, but at a rate of 3 miles per hour. And the total time was 10 hours. And so that is our equation. I will say this for this video stuff. The challenge of these word problems is setting them up. Solving them, I'm going to fly by that, okay? Because if I don't shoot through solving, this video is probably going to be 2 or 3 hours long, okay? We're going to multiply by the LCD, which is 6. So I'm going to get 3D plus 2D equals 60. So therefore 5D equals 60, which tells me that the distance is 12 miles. Of course, that is only one way. Total miles, total distance is actually 2D. So it would be 24 miles. Does that make sense? Okay. All right. Total distance is because you got to go up the mountain and down the mountain. Okay. And there it is. Moving on to number 2. Shelley can paint a fence in 8 hours. Karen can do it in 4 hours. How long will it take them to do the job if they work together? So this is a work rate problem. So I don't know if you want to write that. This is called a work rate problem. If you don't like my explanation here, and want to Google things, Google that. Google work rate problems, Algebra 2. Maybe you'll find some resources that'll help you out, okay, if this isn't enough. So the way work rate problems work is your rate is some task accomplished in some amount of time. And I do believe I said that in the last video. Work is equivalent to whatever task you're doing completed in some amount of time. Okay? Now, in this case, Shelley can paint a fence in 8 hours. So I'd say Shelley, one fence in 8 hours. You know what? I'm going to lasso this. Whoa. Didn't want to grab the M. That's okay. Problem. And Karen can do it in 4. Well, it's how many fences, right? It's one fence in 4 hours. So the task is painting a fence. The task is painting a fence. And you do want to pay attention to how many fences are getting painted. In this case, it's a fence, which is one fence. So Shelley is one fence in 8 hours. Karen is one fence in 4 hours. It's asking how long is it if they do it together. Well, you just add those, right? That's our work. And the question is, how long does it take them together to paint one fence? And we don't know how long it takes, so we call this X hours or H hours. I don't know, whatever variable you like, okay? But you see how the task is painting one fence, okay? The question could have asked, how long would it take them to paint 3 fences? In which case, if it said 3 fences, you'd put a 3 here, okay? But it's just a fence, so we're fine. Okay, so this is a pretty easy one. 1/8 plus 1/4 equals 1 over x. I mean, that's easy, okay? 1/8 plus for this 3/8 equals 1 over x. By the way, I don't know if anybody showed you this before. Let me show you something. Look, you can do cross multiplication, blah blah blah, right? The butterfly is 3x. This is 8. Get 8/3, right? Lame, boring. Too much writing, boring. Let's just take the reciprocal. If it's kind of a proportional rule, maybe you've probably learned this before, but if 3 is to 1 as 8 is to x, well then you could say 8 over 3 is x over 1. So you basically say therefore x equals 8/3. Okay? Look, you can do cross multiplication, fine. But when you have a proportion like this and x is just in the denominator, it's only 1x like this, you could just flip it, okay? You could just take the reciprocal of both sides. The proportion stays the same. And that's just that's a conversation about proportions. So x equals 8/3. It does ask us for hours. If you said we can paint the fence in 8/3 of an hour, I'd probably look at you like, who are you, right? That is 2 2/3 hours, or if you really like, 2 hours and 40 minutes. Okay? I don't care. Express it either way. You can write 8/3 hours. Okay, if you do it on a test, I'll count it right. It's fine. But you wouldn't say 8/3 hour to a normal person. That'd be silly. Okay, level 2. Let's actually get into those were the easy ones. Okay, all right. Level 2. Carlos can travel 40 miles on his motorbike in the same time it takes Paul to travel 15 miles on his bicycle. Paul rides his bike 20 miles per hour slower than Carlos rides his motorbike. Find the speed for each bike. Now, key word here is same time. So you see, Carlos's time is going to equal Paul's time. So Carlos's time is Paul's time. These are equal because of that word same time. And we, remember, said time is distance divided by speed. So I'm going to give these. So are you ready for this? Are you ready? Okay. Carlos's distance. I'm going to call it distance. And I'm going to use a subscript of C to denote that it's Carlos's distance. That's 40 miles. Okay. And Paul's distance, D sub P, is 15 miles. Now, it says if Paul rides his bike 20 miles slower than Carlos, well, do we know how fast Carlos rides? No. So we'll call X Carlos's speed. And if Paul rides 20 miles slower than that, then if you take X and subtract 20, that's going to be Paul's speed. Okay? So it's distance over time. So Carlos's distance is 40 miles divided by Carlos's speed, which is X miles per hour, equals Paul's time, right? It's 15 miles over X minus 20. And now you can do cross multiply. I mean, you can use the reciprocal thing again, but that won't help you solve. So let's just do cross multiplication. I'm going to do 40 times X minus 20 equals 15 times X. I'll distribute 40X minus, what is that? Is that 800? I think that's 800. Equals 15X. And then subtract 15X from both sides. I'm going to get 25X equals 800. And divide both sides by 25. Well, let's see. 25 goes into 100 4 times. So 4 times 8 is 400. Or, I'm sorry. 4 times 8 is 32. So X is 32 miles per hour. Now, notice it says the question is find the speed of each bike. So you're not done, okay? What is Carlos's speed? And what is Paul's? Well, we said X was Carlos, so that's 32 miles per hour. And Paul is 20 less than that, so that is 12 miles per hour. Okay? Whoop. Done. All right. Hope my writing's okay here. I know I'm a little sloppy. Okay. And I'm just going to double verify that 800 divided by 25 is, in fact, 32. Yes, it is. Yay, go mental math. Okay. Moving on to number 2. A plane flies from New York to Chicago. That's about 700 miles at a speed of 360 miles per hour. By the way, I think that's pretty slow for a plane. I don't know how realistic that. I think they usually go like 500 miles an hour. I don't know. On the return trip from Chicago to New York, a tailwind helps the plane move faster. So tailwind means the wind is pushing, like tail side or whatever, pushing the plane forward, okay? The total flying time around the trip is 3.5 hours, okay? So we're given total time. And notice the question is how fast on the return trip, okay? So our goal is to find the speed of return. Okay? Because the thing is, we know how fast he's going to get there, right? Speed going there is 360 miles an hour. The distance, which by the way is both ways, right, is going to be 700 miles. At least we're estimating. And we say that the total time is 3.5 hours. All right. So if you add time going, or maybe I'll say, I don't know. What do you want to say? Yeah, okay, fine. Time going plus time returning. Returning. That's equal to your total time. Right? So again, yet again, time, remember, time is distance divided by speed. So that's all you're doing. So the time is going, well, the distance is 700 miles. The speed going there is 360. Plus the time returning is 700 miles. Oh, but we don't know how fast he's going, right? But we do know this, right? We may not know exactly how fast he's going, but it does say that a tailwind helps him move faster. But it doesn't say how fast the wind is. Okay, so since we don't know that, let's just call that x. Okay, so we'll say that the speed return, because that's what we need to know, is x miles per hour. And then this equals the total time, which is 3.5. Now, I'm going to convert 3.5 to a fraction, 7 over 2. That way it's easier to deal with. Okay? And by the way, I can reduce this fraction right here. Let's see, that is, I'm going to do some scratch work here. 700 over 360, that's 70 over 36, which is 45 over 18. Both are divisible by 9. It's 5 over 2. Okay, so if you simplify that fraction, 5 halves plus 700 over x equals 7 halves. Oh, really? Are you kidding me? That's silly. There's no way that's it. I'm going to have to check my key. Subtract 5 halves from both sides. You get 700 over x. No way. No, I don't buy it. I did something wrong. Hold on. I'm going to get my key. I want you to reflect on that. There's no way I did this right. What is this? Level 2, question 2? How fast was the plane flying on there? What did I do wrong? Ugh. Looking at my key. Oh, did I simplify wrong? Is that what? Oh, dumb, stupid fool. What are you doing? Half of... This is what you get for doing mental math, kids. Okay, half of 70 is 35. Oh, man, if you're watching the video, I'm sure you're frustrated at me saying, make this big. Make this big, that's not right. Okay, 35 over 18. What are those supposed to be divisible by? Anything? 35 over... okay. I can't think... Does 35 over 18 not reduce? Hold on. Okay. And yep, I'm cheating. Resorting to a calculator. 35 over 18. That doesn't reduce, does it? No, I didn't think so. Sorry. I should. Okay. So that's my problem. That's my problem right there. 35 over 18. Yeah, I didn't think it was that easy. Okay. Well, at least I caught it and didn't keep going, yeah? Sheesh. What do we want to multiply by? Let's multiply by 18 all the way through, or 18x, right? That'd be your LCD. Your LCD is going to be 18x to get rid of everything. So if I multiply by that, I'm going to get 35x plus 700 times 18 equals 18 over 2, that's 9. 9 times 7 is 63x. Is that right? Okay, I'm using a calculator to double check. Okay, it's 63. So 63 minus 35, so 700 times 18 equals, let's see, 5, that's 40, 23 plus 5, what's 28x? Okay. So, so x is 700 times 18 over 28. And phooey, I'm not using a calculator for this. Phooey, 700 is 7 times 10. This is 4 times 7. And 100 is 4 times 25. Yeah. Bang, 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 bang. 25 times 18 is x. So let's just do that real quick. 25 times 18, that's 40. 16 is 200. 5, 2, 450. X equals 450 miles per hour. Oh, yeah. There we go. Nice. Okay, and that makes sense. Yeah, because that was my original thing. 360 plus 90 is 450. Fantastic. Okay, sorry for the blunder there with the reducing the fraction. I cut 70 in half wrong. It was not 45, it's 35. Okay, and there's your solution. Okay, the math there isn't that bad, really. By the way, you get a calculator for problems like this, so no excuse for you, okay? I'll tell you what, though. You really want to push yourself. You want to get good at math. You do all of these problems, non-calculator. Yeah? Yeah, that'll make you fantastic. I mean, you will be a god at math if you can do these with no calculator. All right. One pump can empty the town swimming pool in 9 hours less time than a smaller second pump can. Together, they can empty the pool in 20 hours. So how much time would it take the larger pump alone to empty the pool? Okay, that's easy. Yeah. This is another work rate again. Yeah. This is one of those work rate problems. Remember, work is your task divided by time. So just ask what your task is, right? The task is emptying the pool. Emptying the pool. So the first pump, right? We say, I say speed of pump 1 plus speed of pump 2 equals combined work rate. Yeah? I'm going to rewrite that. And while I rewrite that, I want to say something. For work rate problems, you can add speeds together because two things are working together on a particular task and will get it done sooner. Does that make sense? Like, look, if I clean the house at some rate and my girlfriend cleans the house at some other rate, it's faster to clean it together, right? Versus if we clean it separately. And so if you add our rates together, it's accomplishing the same task, but cutting the time short, right? And that's fine. You can add those rates. You can't add speed of two different objects or an object doing speed in a different time interval, if that makes sense. So like that last problem with the plane here, you can't add like speed of the plane going forth plus speed of the plane going. That doesn't really, not unless you're trying to do like an average speed kind of thing. But like two planes moving at two different rates doesn't make either plane go faster. I don't know. Okay, let me just, I hope I'm not confusing. Let me just get on with this problem. Okay, so speed of pump 1, or the work, right, is the task. So it's 1 pool, and it can do this. Oh no, I don't know how long it takes, right? So pump 1 takes, let's see, 1 pump can empty in 9 hours less time than a smaller second pump. So here's what I'll say. I'll say pump 2. Pump 2 takes X hours, right, to drain. And pump 1 takes 9 hours less than that. Pump 1 takes X minus 9 hours to drain. Okay? So the first pump 1, this is X minus 9 plus 1 pool over X equals their combined thing. And together, what's their task? They're still doing 1 pool. And that's going to get accomplished in 20 hours. So this is essentially the thing you're setting up. I'm making sure. Yeah. Okay. So what's my LCD, right? My least common denominator is 20x times x minus 9. So multiply everything by the least common denominator. It's really, really nice that the numerators are all 1. I'm going to get x times 20 plus 20 times x minus 9 equals x times x minus 9. That's a result of multiplying by the LCD. Again, I'm not showing all the little work to do this, okay? You can hopefully figure that out with the LCD and all that business. 20x plus 20x minus, what is that, 180? Equals x squared minus 9x. Okay, this is a lovely quadratic that we get to factor now, okay? We're going to subtract 48, so this is x squared minus 49x plus 180 equals 0. So what and what make that happen? I'm going to guess it's 45 and 4. Is that right? Yep. X minus 45, x minus 4. Yep, that's it. X equals 45 or x equals 4. Now, I'm glad we got to this point because you might say, oh, so it takes, right, if it says how much time would it take the larger pump alone, well, the larger pump is the one that can do it in 9 hours less, right? The larger pump, and maybe I'll say speed, is the x minus 9. Now, if x equals 4, then x minus 9 is 4 minus 9, which equals negative 5. And that is bad. Would you agree? Why is that bad, you might ask? I was trying to circle this. No. And that's because speed's not going to be negative. So we reject the x equals 4 answer. And so we'll say if x equals 45, then x minus 9 is 45 minus 9, which is 36. So it takes 36 hours for the larger pump alone to empty the pool. Whereas it takes 45 hours for pump 2 to do it. Okay? Okay. Oh my God. We're doing great. Let's keep going. Alrighty. An elevator went from the bottom to the top of a tower at an average speed of 4 meters per second, remained at the top for 90 seconds, and then returned to the bottom at 5 meters per second. If the total elapsed time was 4.5 minutes, how tall is the tower? And I did write that down, right? 4.5? Hold on. I want to make sure. Yeah, I think so. Okay, so time up plus time down equals total time. Are you starting to notice a theme here with the times? Kind of like I said at the beginning of the video. And again, remember, time is distance over speed. So what is the distance going up? Oh no, I don't know that because the question asks, how high is the tower, right? What is distance? D. Yeah? So let's call D is distance up tower. Okay? We don't know what D is, but that's what we're trying to find. Okay? We do know that the speed going up and down, right? Speed up is 4 meters per second. Speed down is 5 meters per second. And now ask yourself what total time is. Total time. Well, it says that the total time elapsed was 4.5 minutes. Right? However, it remained at the top for 90 seconds. So it wasn't moving for 90 seconds, and that's not going to help us figure out the time up versus the time, right? Because time up plus time down equals the total time moving, not just the total time. So perhaps we should say total time moving. Yeah? The total time moving is total time minus stationary time. And what do I mean by stationary? I mean it's not moving. Yeah? Stationary. All right. So your total time is 4.5 minutes, 4.5 minutes, minus 90 seconds, but that's 1.5 minutes. And I might go write that right here. 90 seconds is 1.5 minutes. Okay, so your total time is 3 minutes moving. Okay, so all that's there. So let's take this, okay? Time up. Time up, some distance divided by the speed going up is 4. Plus, time down is this distance over 5 meters per second equals your total time, but total time moving, which we said was 3 minutes. Okay? However, asterisk. Speed is in meters per second. Speed is in meters per second. Put time in seconds. Okay? So it's not actually equal to 3 because our units wouldn't match, right? You're saying meters per second. It needs to be in terms of seconds. So it's 3 minutes, that's 180 seconds. Okay? Now you can do this. Okay. So we've got this old big thing. I'll just draw an arrow here. The LCD is 4 times 5, that's 20. So we're just going to multiply by 20 all the way throughout. I should get 5D plus 4D equals 180 times 20. That's 9D equals 180 times 20, and then we're going to divide by 9 on both sides. So therefore, take this. I say D equals, well, that's 18 times 10, so that's 9 times 2 times 10 times 20 over 9. Cross those out. So we're back to 20 times 20. So D equals 400. And that is D. The D is the distance. That's the height of the tower. So it is 400 meters. Please, please, please express your answer in terms of the units. Look at what I'm doing for number 3, for number 4, for all of these. You see how I have units on every single one of these? I swear, if you don't put these units, please, miles, hours, or minutes, or miles per hour, your science teachers should be making a huge fuss about this because it matters a ton. Like it does, okay? Yes, we're in a math classroom, blah, blah, blah. Who cares? In the real world, though, if you don't pay attention to units, you screw up the problem big time, okay? Big time you screw up the problem. So please pay attention to those units. They are crucial. Okay. Let's move on to level 3. We're doing good so far. I'll tell you this. The majority of your word problem test questions are going to look like level 2. However, that ain't to say that a level 3 won't pop on there. Okay? So these are still important to practice. But I wouldn't throw 4 of these at you on a test. That would be overkill. But I could throw 1. Okay. Here we go. Level 3. They're still the same premise. Okay? They just involve a little bit more thinking. A train averaged 80 kilometers an hour for the first 100 kilometers of a trip. If the train averaged 96 kilometer hours for the entire 240 kilometer trip, what was the average speed of the train on the second part of the trip? So here's what I'm going to do. I'm going to say F is for forward and B is for back. Okay? Your distance going forward was 100 kilometers. Your distance going back, well, it's the entire 240 kilometer trip. So that's actually 240 minus 100, which is 140. By the way, these are in kilometers. Okay. And your total distance is, of course, 240 kilometers. Yeah, so that's your distances. Your speed going forward, so speed going forward is 80 kilometers an hour. And then it says the train averaged 96 kilometers for the total. So the speed total is an average of 96 kilometers per hour. Okay? And it's asking for what is, right, the question, what was the average speed for the second part? So what is the speed going backwards? Yeah? Well, if I add time going forwards plus the time going backwards, I get the total time. And as we've established, time equals distance over speed. Do not forget that. So it is the distance going forward divided by the speed going forward plus the distance going backwards plus the speed going backwards equals the distance total divided by the speed total. So plug in all these things from over here on the side. Distance going forward, 100. Speed going forward, 80. Plus distance going backwards, 140. Speed going backwards, I don't know that. Keep calling it SB. Equals distance total, 240, over total speed, 96. Now, let's reduce these fractions. I'm going to do a little bit of side work here. 100 over 80, that's 10 over 8, which is 5/4. Okay, so this equals 5/4. And 240 over 96, well, cut that in half. That's 120 over, what's 96 cut in half? Well, 90 is 45, so is it 48? Yeah. Okay. And then both of those are divisible by 12, so 10 over 4, which is 5 over 2. So this equals 5 over 2. So, woo. Oh, that didn't make a woo. Okay. So if I use my new fractions, 5/4 plus 140 over SB equals 5/2. Well, that's easy. 5/2 minus 5/4. Well, 5/4 is half of 5/2. So it's 140 over SB equals 5/2 minus 5/4. You will get 5/4. And then you can, if you do cross multiplication, you will find that 5SB equals 140 times 4. Therefore, the speed backwards is 140 times 4 over 5. So that is, that's 14 times 10 times 4 over 5. So it's like 14 times 8. Okay. What is 14? I don't want to do that in my head. 14 times 8. 2, 3, what is that? 11? That does not seem right, Mr. Spake. There we go. 112. Cool. Speed going backwards equals 112 miles per hour. Oh, yeah. That felt good. I like that problem a lot. Oh, I really like that problem. That's really good. Fantastic. Okay. By the way, do you see how I'm manipulating these fractions by hand? No calculator? Look, it's fine. Some of these problems I'll let you use a calculator on, but honestly, you need to get to a point where you don't need it. You just do. You will improve your mathematical ability leagues if you practice this without a calculator. Okay? It'll improve your algebra skills. It'll improve your numerical competency. So it's just a recommendation. Okay, move on to number 2. How long is this video? Oh my God. Okay, Alex averaged 55 kilometers per hour for the first half of his trip. How fast would he have to travel during the second half of his trip for him to have an overall average rate of 60 kilometers for the whole trip? So, again, we'll do time 1 and time 2. Yep. The first half, okay? We'll say time 1 plus time 2 equals time total. Yep, same old, same old. So it looks like we don't have distance, right? And what's the question asking? Make sure you know. It's asking how fast, right? It says how fast during the second half. So what is speed 2? Okay, what is the second speed? We don't know distance. So I'm going to say here, we don't know distance. So, well, I suppose there's 2 ways about it you could go. And it doesn't really matter what you choose. I'm going to do it this way. Okay? Let D equal the distance halfway. All right? Now, look, you can say that D will be the total distance. That is fine. And then you can use D over 2 as something. But I'm just going to, the math will work out a little bit easier if you just say that D is the distance halfway. But again, I'm going to say it again. You can say that D is the total distance, but it will change the look of the equation. You will still get the same answer. Okay, so don't worry about that. Now, I do know that his first speed is 55 miles an hour. And I know that his average speed, so I'll say total, right, is 60 miles per hour. The distance halfway, right, is what we're going to use for time 1 and time 2. This tells us, by the way, therefore, 2D is total distance. Does that make sense? Right, if D is the distance halfway, then 2 times D is the total distance. Okay. So time 1 is D over 55 miles an hour, plus time 2 is D over, we don't know the second speed, S2, equals time total, which is, it's the total distance over the average speed, like so. Yeah? And that's how we get that. So, and you might be saying, Mr. Zweig, what are we supposed to do with the D's? And I'll show you in just a second, okay? Identify your LCD. Your LCD is 55 times S2 times 60. By the way, you don't have to call that S2. I'm using S2 as a label to tell me that I am looking for the second speed, the speed for the second half of the trip. You could say that X is speed on a second half. But I'm calling that S2. Okay? Because it helps me remember like what variable I'm describing. Because X is just, what the heck does X tell me? Yeah? All right. So let's multiply by this guy right here. If you carry out this multiplication, I think you'll find D times S2 times 60 plus D times 55 times 60 equals 2D times 55 times S2. Now notice you can divide everything by D. Look, divide this side by D and divide this side by D. If you do, and maybe, look, I'll write it as if you just divide every single term by D. Because you have a D in every single one of these terms, those distances cancel. So effectively what's happened here is you didn't know how far the distance was, but you didn't really need to. We sort of use distance as a dummy variable that honestly just in the end ends up canceling anyway. So there was not really ever a need to know the distance. So now I know it's 60 S2 plus 60 times 55 equals 55 S2. Now I'm going to rearrange, right? I'll subtract 55 S2 to the other side. Minus 55 S2. And then I'll add that other thing to the other side, right? Is it minus? Hello? Hold up. Did I make a mistake? Where is it? This. Oh. The D's canceled, but not the 2's. Silly Mr. Spake. Okay. It was right here. Yeah, I thought so. Okay. Phew. See the 2 there? Don't forget the 2. The D's canceled. But this is still 2 times 55 S2. Okay? So this is 60 S2 plus 60 times 55 equals double that. That's 110 S2. Now I'll subtract 60 S2 from both sides. I get 60 times 55 equals 100. That's 50. And then you divide both sides by 50. So S2 equals, and now I'm going to break this apart. 60 is 6 times 10, and 55 is 5 times 11, and 50 is 5 times 10. So 5, 10, 10. 6 times 11 is 66 miles per hour. Booyah! And that is what I got. So S2 equals 66 miles per hour. Okay. Whew. Yeah, okay. These take a while. These take a while to explain. Okay. This one was tricky because you didn't know what the distance was. And again, you didn't really need to. And again, do you see how I'm manipulating all this stuff without actually carrying out the multiplication? Do you see how you don't really need a calculator if you keep things in factored form, right? I didn't multiply 60 times 50. Who would do that? Who would do that? Not unless you absolutely need to. This is actually easier to work with if you just keep it this way. All right. Let's go to the next. Oh, we're almost done. Oh, my God. I want to go to bed. All right. Members of the computer club were assessed equal amounts to raise $800 to buy some software. When 5 new members joined the club, each member's share was reduced by $8. What is the size of the new club? Well, I know, here's what I know. It was $800, right? So cost equals $800, like so. Let's call X, because I don't know how many people the original club had, right? Number of members originally. Yeah. And because 5 new members joined the club. So X plus 5 equals number of members now. Yeah, because 5 more people joined. Okay. You don't have to use X. I'm just using X for this because I don't think we have any other complicated variables. And it says that each member's share was reduced by $800. And we want to find the new size of the club. So our goal, what is the new size of the club, is actually saying what is X plus 5 equal to? Because we don't want to just find X, we want to find X plus 5. It's the number of members now. Yeah? Well, if you take cost, right? Take cost and divide it by number of people. This equals the cost per person, right? And it says that each member's share was reduced by $8. So the original price per person, it says the new share is reduced. So if you take the original and you subtract $8, you get the new price per person. Does that make sense? Right? You take the original, everybody owed some original price, but now that new people joined, that new price per person is $8 less than the original price per person. Now, the original price is the cost divided by the number of people. So the cost is $800 divided by the original number of members, X, because it's, right, because X is the original ones. So $800 per X, these are original. Sorry, I don't like the way I'm writing that. X, and I say this is original members. Okay. Minus 8, just as a whole number, equals the new price per person. Now, look, they still have to, the club is still needing to afford $800, but the new amount of people is X plus 5. And this is the new club size, right? It's the new members. It's X plus 5. Okay. Yeah, I don't like this parentheses. Boom, boom. Okay, so let me clean this up. It's 800 over X minus 8 equals 800 over X plus 5. So your least common denominator is X times 1 times X plus 5. I'm not going to write the 1. So you're going to multiply by the LCD, carry through that out, and you'll have 800 times X plus 5 minus 8 times X plus 5 equals 800X. Okay, so let's distribute this. 800x plus 800 times 5 minus, this is 8x squared minus 40x equals 800x. And notice I have 800x on both sides, so I can subtract those. And then, let me, just move it all the way up here so I have some space. So then 800 times 5 minus 8x squared minus 40x equals 0. All right. Well, you can divide all this by 8. So 100 times 5 minus x squared minus 5x equals 0. Rearrange this so that it's x squared plus 5x minus 100 times 5 is 500 equals 0. Yeah? Nice. And then you can try and factor this. So it'll be x plus something, x minus something equals 0. What do you think? What works? How do you factor? Remember, if you're truly in doubt, if this takes too much time, you can always use quadratic formula, right? It's kind of a way to cheese it. I think it's 20 and 25. X plus 25 and x minus 20. Is that right? Do you think so? I'm pretty sure that's right. X minus 20. Because look, 25 times 2 is 50. So 50 times, right? So yeah, that works. Cool. Therefore, x equals negative 25 and x equals positive 20. But we reject that because number of members is not negative. But remember, what was the goal? Right? The goal was, what is x plus 5? X plus 5 equals 20 plus 5. So our answer is 25 members. Boom. That's the size of the new club. The old club was 20 people. Please be sure to read the question and understand what it is asking for. Okay? Be sure for that. Okay, number 4. We're getting there. All right. With a north wind blowing at 20 miles per hour, a helicopter flies due north for 30 miles. The helicopter then lands and remains on the ground for 12 minutes before returning to its home base. If the helicopter was gone for exactly 1 hour, find the helicopter's rate in still air. Okay. So I'll say N for north and S for south. Okay. So N north, S south. Right, because he's going north and then he's going to go south once he goes back. So the north wind is blowing at 20 miles an hour. So the speed, I don't know what the speed in still air is, right? So I'll call speed in still air. That's my unknown. We're going to call that X. Okay? Now, the speed going north is the speed in still air X, but the north wind is blowing 20 miles an hour. So it says north wind blowing. That means the wind is blowing north, and if the helicopter's going north, it means it's pushing along with it. So that 20 miles an hour is going to add to the speed of the helicopter in still air. Now, if it starts flying south, the speed south is going to be x minus 20, right? Because it's going to push against, assuming that that north wind is still blowing at that constant rate, which we are working under that assumption. And it flies north. Yeah, I'm sorry. I just noticed kind of a kind of logic flaw with the problem. Who says that home base is the same direction as the original liftoff, right? I mean, who says? I don't know. Okay, anyway. Sorry, I'm overthinking. But the distance north is 30 miles, but so is the distance south, right? At least we're working under that assumption that it's going back and forth. Now ask yourself, what's the total time in flight, right? Time in flight. Flight. Well, that equals your total time. This is like the elevator problem minus time not flying. Or you could say time stationary. Okay? Which, by the way, we want this in hours. So this is 1 hour minus 12 minutes. Well, let's do a unit conversion here. 12 minutes. 12 minutes is, well, 12 out of, right, 12 minutes out of 60 minutes is 1/5 hour. So this is 1 hour minus 1/5 hour. So 1 minus 1/5 is 4/5 hours. We had to make sure of that unit conversion there. Okay? But now you've got your time in flight, so we're good. We've pretty much got it all going here, right? Because just like all these other problems, this is your time going north plus your time going south equals time in flight. I really need to zoom in so I can write better. Time in flight. So, again, remember, don't forget, time equals distance over speed. We use that all day. Distance is 30 miles divided by speed going north is x plus 20. Plus another 30 miles going south, but it's x minus 20. And time in flight, we said, was 4/5 of an hour. Okay? Cool. And now you just want to solve. So the LCD is x plus 20, x minus 20, and also times 5. All right. So let's take this and just move this up here and multiply. So multiply by your LCD, you're going to get 30 times 5 times x minus 20 plus 30 times 5 again. And then that's x plus 20 equals 4/5 times, so it's 4 times x plus 20, x minus 20. 4, ow. Okay, hold on, everybody. Lasso tool time. I ran out of space, that's all. 4 times x plus 20, x minus 20. Raw. Okay, cool. Are you ready for some fancy business here? Are you ready for this? This epicness? 30 times 5, that's a common factor. So actually that's 30 times 5, bracket x minus 20 plus x plus 20. And the x's cancel. Boop, boop. Or sorry, not the x's, the 20s cancel. Boop, boop. And over here, let me stick with the same color, blue, so it doesn't look all wonky. 4 times, this is a difference of squares, x squared minus 400, right? Because 20 squared, 20 times 20 is 400, so that's a difference of squares. So really this is 30 times 5 times 2x is x plus x equals 4x squared minus 4 times 400. I'm not going to do that in my head. If you divide everything by 4, see, look, this is 2 times 15 times 2x equals 4x squared minus 4 times 400. If you divide by 4, divide by 4, divide by 4, then those 4's cancel, those 4's cancel. 2 times 2 is 4, cancels with 4. Oh, I forgot a 5. Don't forget your 5. Hold on. Your 30 was 2 times 15, but you had this 5 here. So times 5. Those 2's cancel. Okay, and so I've got 15 times 5x equals x squared minus 400. Rearrange this. You should get x squared. 15 times 5 is 75? Is that right? Minus 75x minus 400 equals 0. Now let's factor that. This is it. We're almost there. We are so close. Oh my God. What times what is 400, guys? Please help. My brain is about to just blow out right now. Just totally implode. I can't think of... What is it? What is it? Oh, Mr. Spake, you can't poop out now. I'm sure it's staring me right in the face. 80. Stupid. Okay. X minus 80 and x plus 5. Got it. Booyah. Right, because 8 times 5 is 40. Duh, come on. That was not that bad. 8 times 5 is 40, so 80 times 5. Yeah, it works. Okay, so therefore, x equals 80, or x equals negative 5. But negative 5 is a silly answer. I say that's silly. It is not negative 5, right? It's got to be 80 because x is speed. And that is the still rate in this. So we did answer the question right. Find the helicopter's rate in still air. Speed in still air is x. So x equals 80. So I say, therefore, x equals 80 miles per hour. Boom. We're good on that front. Okay. It is midnight, and I don't know how long this video is, and I want to stop. But there are only 2 questions more. Wow, look at all that work. Oh, my God. Okay. Should I do this? Find 2 positive numbers that differ by 8 and whose reciprocals differ by 1/6. Maybe. Let me see if I can get it. 2 positive numbers. So call one x, call one y. X, y. That differ by 8. So x minus 8 equals y. Who cares? And their reciprocals differ by 1/6. So 1 over x minus 1 over y equals 1 over 6. So what is this, a simple substitution? So y equals, I already solved for y, silly. Y is x minus 8, so therefore 1 over x minus 1 over x minus 8 equals 1 over this. See, that's a substitution problem. So LCD is 6x, x minus 8. I put this in level 4. This is easier than anything I've done all night. You kidding me? Why did I? This doesn't belong in level 4. This belongs in level 0. Easy peasy. 6x minus 8 minus 1 times, okay, this is 6x equals x times x minus 8. So 6x minus 48 minus 6x. Wow. Those cancel. Equals x squared minus 8x. Oh, pff. What is this baby? This baby quadratic. Look at that. 12 and 4. X minus 12. X plus 4 equals 0. Therefore, x equals 12 or negative 4. Of course, you do want to check that out. So if 12 is 8, so let's check both. You got to verify both solutions, right? By checking for extraneous kind of thing. You have to make sure they both work. So if x equals 12, then y equals 4. And now we check the other equation. It's 1 over x minus 1 over y. So is 1 over 12 minus 1 over 4 equal to 1 over 6? No, it is not. So I say no. No. Sorry. No. Okay. If x equals negative 4, then y equals negative 12. So then 1 over negative 4 minus 1 over negative 12 equals 1/6. Well, that's 1/4, or sorry, let's make that in terms of 12ths. 3/12. Oh, is it double negative? Plus 1/12 equals 4/12. Am I doing this right? Oh, it's negative 3/12. So that don't work either, it doesn't? It's negative 2/12. Negative 2 is a negative 1/6. Did I do something wrong? 1 over x minus 1 over x minus 8. 1 over x minus 1 over x minus 8. And then say y equals 1/6. Are you kidding me? Are you telling me there's no solutions? No, I feel like this had a solution. Did I set it up wrong? Okay, so with my current setup, it looks like I set it up 2 positive numbers that differ by 8. Oh. Oh, idiot. Idiot. Sorry, I'm not a fool. I'm just tired. Sorry. Their difference is 8. X minus y equals 8. Oh. Oh. So y... Oh. No, that's... What? Y is still x minus 8, though, actually. Um... I don't know right now. I didn't work this one ahead of time. All the other ones I worked and I had a key to check just to be sure. I mean, I still did them from scratch. I wasn't copying my key. I guarantee you that. Oh, that's so funny. Remember how I said that this was easy and that this belongs in level 0? I think I have the key somewhere. Oh, you see, I want it to be in the video so you know it. I feel like I'm close, but I'm x minus y equals 8. And whose reciprocals differ by 1/6. Oh, okay. I think I know what I did wrong. Okay. It's really close. It's really close on the right track. Don't you love this? Don't you just love Mr. Spake making mistakes and then you getting to learn from it? So if x minus y, think of it like this, right? Positive minus, well, whatever. X minus y equals 8 means x, right? This means x has to be greater than y. And if you take their reciprocals, then that, therefore, 1 over x is less than 1 over y. So what I did wrong was I set up this bottom reciprocal wrong. It's 1 over y minus 1 over x. Because if their difference is going to be positive, you have to set it up so that it's the bigger fraction minus the smaller fraction. And that was my mistake. So really, you make this here, and you adjust this x. Okay? And a lot of the math is still the same here. We're gonna just really quickly fix this super fast. If you caught this mistake, congratulations, because I'm flew right over my head tonight. Yeah. So it was x minus 8 minus. Wait. Okay, sorry. Yeah, 6x minus 6 times x minus 8 equals this. So yeah, so it's your 6x minus 6x plus 48 equals x squared minus 8x. Those cancel. I got x squared minus 8x minus 48 equals 0. So it's x minus 12, x plus 4. I think this is the opposite signs is what I got before. So x equals 12 and negative 4. But I don't think we're going to do negative 4. I think we just can reject that answer. So if x equals 12, then it's 1 over 12 minus 8 is 4 minus 1/12. Yeah. There we are, buddy. That's 3/12 minus 1/12 equals 2/12, which equals 1/6. Check. check. And I believe the -4 solution is extraneous. So x equals 12 and y equals 4. Boom. Okay, so you know what? Maybe that problem was harder than I thought. Because of that little tricky business of setting up your equations. The solving part isn't what was hard. It was the setting up. Okay. Well, I guess I'm already here. What's another 10 minutes, right? The reciprocal of half a number increased by half the reciprocal of a number is 1/2. Find the number. Okay, let's call x the number. X is the number. So the reciprocal of half a number. So I'm going to underline that blue. The reciprocal of half a number. I'm going to say the reciprocal of 1/2 x, right? Or maybe you can think of it as x over 2. I mean, it's the same thing, but right, because half the number, if x is the number, half of that is x over 2. So the reciprocal of x over 2 is 2 over x, right? And then is increased by half the reciprocal of a number is half. Oh, I don't want the half. It's increased by half the reciprocal of a number. So half of 1 over x, because the reciprocal of a number, that's half of 1 over x, is 1 over 2x, because you double the bottom. All right, it's a half times x, 1 over x. So if you wanted to see, right, it's doing a half times 1 over x, which is 1 over 2x. Okay? And you're increasing. Increased means plus. So 2 over x plus 1 over 2x equals a half. I think that's the equation. So the LCD is just 2x. So multiply by 2x. That's 4 plus 1 equals x. Okay. Okay. So x equals 5. Done. Got it. Booyah. Did it. All right. I have no idea how long this was. This was insane. This is the most insane video I've done yet. There's just so many problems. Okay. Yeah. So see how I said, if you do all of this, you are 100% prepared for the test. I mean, at least as far as word problem solving and operations go. This will hit just about every skill you need. It doesn't cover partial fraction decomposition, though, so, I mean, that might be on the test. So, and it also doesn't cover inverse variation. So maybe it doesn't guarantee 100, but my goodness gracious, it sure means you know it. So thanks for watching this video. If you watched this all the way through, pat yourself on the back. And if you did all of these problems on your own and just wanted to check, job well done. Okay. I'm going to go now. I am tired. Thanks for watching. I'll see you later.